When the salts melt, an increase in volume is observed, amounting to 10–25% compared to the initial crystalline form. Structural analysis indicates that the distance between oppositely charged ions in the melt remains particularly the same as in the solid electrolyte. These data can be explained in terms of voids or holes in the structure of the ionic melt. Comparison of the structure of the crystal and the corresponding liquid showed that only the short-range order of the arrangement of the ions is retained in the liquid, while the second coordination shell is largely disrupted. Holes in the melt move continuously, form and disappear, increase in size or become small. The average hole radius is close to the average ionic radius. Holes are formed due to the thermal motion of the components of the liquid, and also when ion moves from the bulk to the surface when the substance melts. The distribution of holes plays an important role in the transfer process in melts.